Good morning, everyone. So, after a short break from teaching, that is Diwali holidays, we uh, again meet for the online lecture. So, I again welcome you all and a very good morning to everyone. In the last lecture, before Diwali holidays, we have started unit number 6. Okay, so uh, in the last lecture, we have just started the unit number 6 and we have seen a small introduction of unit number 6. Now, in this lecture, we will start actually the syllabus of unit number 6. So, please, anyone unmute yourself and tell me, am I audible or not, so that I will go further next. Just anyone unmute yourself and tell me, am I audible or not?
Yes, sir.
Because I'm using a different headphone. So if it is not clearly audible, then I can replace the headphone or the arrangement. So anyone just unmute and tell me, am I audible? Your screen is visible or not?
Yes, sir.
Yes.
Yes, sir.
Anyone unmute and tell me, am I audible? Yes. Am I audible?
Yes, sir.
Monali Bangre. Okay. Yes, sir. Okay. So okay, we'll proceed for the unit number 6. So this unit basically based on the applications of a circuit, what we have seen in unit number say third, unit number fourth, and unit number fifth. Okay, so that circuits we use here as an application. For example, converters are used for conversion of AC to DC or DC to AC or DC to DC and vice versa. Right. So these applications that okay. So in first unit we have seen the devices, its characteristics, its protections right. So because I know the video is somewhat lagging, even it breaks. But if it is already we have seen learning objectives, introduction that already we have seen in a last lecture, high voltage DC transmission. Now this is one of the most uh, important, we can say, or maybe interesting topic in power electronics because in this high voltage DC transmission, the converters AC to DC as well as DC to DC and DC to AC, all three type of converters can be used. Okay, so it is one of the vital application in power electronics. So there are some disadvantages of AC transmission, but already we discussed in the last lecture. That is, number of wires required more, then losses are more, that is cost is also more to install more than 3 wires. So big towers are required to install, and using that towers connect more than 4 5 wires and transmit the AC one from one place to another place. So it is quite difficult and even complicated system and costly, right? So even if you want to transmit the power through water or underwater, then sometimes it is very difficult. Okay, so AC transmission dominate electricity supply by virtue of pace of generation, motor characteristics, and ability to change voltage magnitude using transformer. In recent years, it has been found that to be economic to transmit large amount of power for a long distance or across water by means of high voltage DC rather than multi-phase AC. The saving in the cable cost, that is advantage in a DC. So whatever necessary equipments required to convert AC to DC and DC to AC, that can be accomplished in the cost of cables. Then many hundreds of megawatt of power are now transmitted by this method. This method is also has additional very important operational benefit in that the two interconnected system can be different frequency. This is most important actually because uh, at your primary side you can have different frequency because we convert that into the DC, and again at the second terminal we convert that DC into AC with a variable frequency. So there is no requirement of synchronization of frequency with the input or transmitter station with the receiving station. This is the overall layout of a DC transmission system that already we have discussed in the last lecture. So AC supply may be a single phase or maybe a three phase. Then filters are required to remove the EMI, that is electromagnetic interference. Then transformer, right? It may be a step up, step down depending upon your requirements. Then converter, AC to DC converter. Already we have seen various type of converters, single phase, then semi converter, then three phase converters, right? So already these converters we have seen in unit number 3. So according to the application, the converters are used. Then again, inductor is used for removing any kind of fluctuation. Then again, using filter, and after that, a pure DC is transmitted through a wire, single wire or a two wire system. At the receiving station, again there will be a first filter which remove the any interference added with the two wire system. Then again a high value of inductor. Again it removes. Basically this forms a LC filter, L and C. So LC filter at the output of transmitting station as well as at the input of receiving station. So this is required. Okay. So this is the filter circuit. Then again a converter. This converter is DC to AC converter. DC to AC converter, it means it's an inverter, right? So inverter again, according to your requirements, you can connect the inverter, that is single phase inverter or a three phase inverter. So according to requirement means depending upon an input power or maybe a required output power. So normally three phase inverters are used. After that, transformer for step down purpose. Again, a filter to remove any electromagnetic interference, high frequency components that can be removed, and then you will get a pure AC, right? And this AC you can maybe distribute in a home or offices. So this is the overall layout. So you can observe this particular figure in which at the input side there will be a AC supply. At the output side again there will be a AC supply. So first AC converted into the DC, and again at the output side or receiving station DC converted into the AC. So what will be the frequency of AC input and what will be the frequency of output, that is receiving station? So that frequency may be differ, and that is the major advantage of this DC transmission system. Okay, so this is overall layout where there are various HVDC transmission systems. Okay, so monopolar HVDC transmission system, bipolar, homopolar, and back-to-back tie connection. So these are the types of HVDC transmission systems. Okay, so we'll see one by one. We'll go first for monopolar high voltage DC transmission system. We can see the block diagram of monopolar. You can check here AC input. This is the converter, AC to DC converter. There will be a single wire. There will be a single wire used to transmit DC from one point to another point, and earth itself considered as a ground, or you can say second terminal, right? So one terminal of this converter is given to the earth, maybe for a longer distance, somewhat maybe meter, some meter, 100 meter, 500 meter, 1 kilometer, up to the distance. This wire is directly inserted into the earth. So earth itself acts as a second terminal, that is ground terminal, for transmission of DC from one point to another point. Every DC has a two terminal. This will be the positive terminal, and this earth itself acts as a ground terminal. So no need to connect any in submarine applications. Okay, so second one is a bipolar DC transmission. Okay, so in this system we can see the PE, due to different polarity of a pole, the system is described as plus minus kVA rating. You can see here the block diagram of bipolar system in which there are two wires. So the two converters, this will provide negative, this will provide positive, and middle terminal is earth. So actually it is a three terminal system, right? Two wires, one is positive, another is negative, and middle or earth itself acts as a return conductor. Okay, so return conductor normally placed from the station, that is away from the station, having distance of 100 meter to 1 kilometer, and in this system, you can see here, due to the different done to avoid the gap mono okay, so I just stop my video so that the internet connectivity speed will be maintained. So in this particular homopolar HVDC transmission system, this type of system has two poles of the same polarity and earth as the return path as shown in figure. Transmission between converter substation is carried out using two separate conductor lines. However, at the end, they are connected together to a common pole feeding converter substation, similar to the monopolar system. The two poles lines can be separate transmission lines having independent tower or Okay. Uh, so again, right? So uh, I just request you to give your attendance. Very poor internet connectivity is there. Last 5 to 7 minutes are remaining, but start to give your attendance, and we'll continue the lecture. If it is again break due to poor internet connectivity, then we will stop the lecture. Okay. So here, this is called actually a homopolar system. So in this system, there are two poles of the same polarity, that is positive, positive or negative, negative, and Earth as a return path, as shown in figure. Transmission between converter substation is carried out using two separate conductors. However, at the end, they are connected together to common pole feeding converter substation, similar to the monopolar system. The two pole lines can be separate transmission lines having independent towers or supported by same tower. Primary side there will be a converter, secondary side there will be a converter. Okay, at primary side there will be a conductor, then at secondary side another converter, and these are the two poles. This is the pole 1 and another pole 2. Okay, so this is called homopolar system. Then back to back HVDC type substation called back to back HVDC system. The system has no DC line between converters. Station, rectifier and inverter mode are of the same location as shown in figure. Next slide, rectification and inversion is done by back-to-back converter. Two adjacent AC networks which are geographically close to each other can be tied up using this system. remaining students give your attendance very fast because the internet connectivity is very poor, so it maybe fails very soon. So before that, you will give your attendance. Now, advantages, as already we discussed, the advantages of DC transmission system. But this is one of the question. It may be asked in examination many times. Advantage and disadvantages of DC transmission system or AC transmission system. So uh, the power on each DC pole is independently controllable. This is the first advantage. No reactive power transmission problem and hence ideally suited for cable transmission. Intermediate switching stations are not required. This is required for AC, but for DC it is not required. System is stable and its stability depends only on thermal capacity of line equipment. Then lightning never hits both the poles of a bipolar transmission line, but it can hit simultaneously both circuits of an AC double circuits. The DC lightning fault can be quickly cleared as compared to the comparative large